never ever, complaining, well, nobody actually helped me when I tried to solve the problem. That is totally impossible. I gave you tons of, information how to solve the problem, how to can get the information. If you cannot get that, that's your problem. Got it? All right, good. Thanks. Okay, I really missed you guys so much. I just missed it. You didn't?
We also.
Yeah, that's like it. Well, actually, one of my PhD students gave you kinetic lecture. I hope you fully understand what he taught you. So, well, actually, the first time we have started with the very simple tool, how to understand, how to describe the environmental problem. And then I introduce you some of the most important environmental problems. For example, we are dealing with what? Ozone depletion in stratosphere, right? And then I just gave you how that happened by the using environmental chemistry, bunch of reaction mechanisms. I don't think that is difficult if you just read it and write it down, and you can fully understand. All right. And then, based on that reaction mechanism, what can you do is you can decide where to go. Is it right? You have severe, reaction equation, chemical equation, and you know which one is important. If you stop that, you can stop the full reaction, right? So that is what you should do as a scientist. So that is the reason why you scientists know the reaction mechanism fully at first time, and then try to go to the parliament and then talk to the stupid people, politicians. You should this because of this reaction mechanism. We can do this, right? You understand? So we are learning, and also one important thing is most of the people living on the earth nowadays, they know, the disaster, environmental disaster nowadays. Well, I've been there, not Fukushima. Fukushima, nobody can enter right now. But it is around the 50 kilometers away from that place. There is Tohoku University, very good university in Japan. Well, actually, KAIST, Post-Tech, and Tsinghua, Dongji, Beijing, and Kyoto, Tokyo, 7 universities are doing environmental research conference together. So this year, the title is Environmental Disaster. We have talked about the some important issues, and then we had a site visit, actually. It was terrible. Can you swim? A little bit.
Yeah.
What do you mean by a little bit? In Korean, can you play tennis? If said, he is not Korean. If he said, yes, I can play tennis a little bit, that means I'm the expert in tennis. Yeah, it is just like the Roger Federer level, because they are very shy, and also they are very moderate. Well, anyway. You can swim, right? That means you can swim maybe 500 meters or 1 kilometer, right? Or can you swim? Have you ever tried to swim at the sea? Yeah, that is very, very great. You guys really, need to learn how to swim because it is related to survival. That is very, very important. Well, swimming, pool swim is, well, you can go fast. But the important thing is, when you go to the sea and swim, you cannot do it easily. Think about that. The tsunami struck the Sendai area. Well, this is Japan. Japan is very large, island. And here, Tohoku, and here, Fukushima, and around the 100 kilometers. I went half, here. I really don't, remember the town's name. But anyway, the town actually just went away. I cannot see the, anything, on that place. So here, the wave, actually, top area, 10-meter wave actually struck the Tohoku, the seashore. And then here, around the 20-meter, and here, 30-meter. Wow, think about it. You are, near the shore, and you can see the wave 30-meter approaching you. Can you see that? Because I think I can swim that situation. Because I'm Iron Man. Iron Man. Not the Iron Man, using the palladium catalyst, Lord Downing Jr. actually played the Iron Man. I'm not that type of Iron Man. I'm just running, biking, and swimming Iron Man actually. I thought I can do that. But when I just watch the building stricken by the tsunami, I cannot say that because the concrete structure almost not destroyed. So that means the 10-meter of the tsunami is not just water. It is kind of 10-meter of rock is approaching you. So what happened in front of the tsunami is you can get crushed. Your body actually can get crushed. So never ever try to swim, against the nature. That is very, very stupid, thought, I think. That is very, very important. I'm not kidding, And also the trauma the Japanese people now have is very, very significant. Some of the Tohoku University undergraduate students, there is, 3 or 4 students already, commit suicide actually, because they saw, the man actually, woman died, in front of his eye. Well, this is very similar. Have you ever seen the view of the, put the livestock because of the mouse and foot disease last year in Korea? Maybe 10,000 stock. People actually buried the livestock under the ground, 3 meters, because there is no solution. We need to kill them. Well, it is very. Don't make such kind of so. That is the same thing actually. German Nazis did it, old days actually. Well, have you heard about the Hawkerain? The bulldozer driver got some trauma after doing that. They have really had very severe mental problem. Why? Which animal can easily kill? Is it cow or is it pig or chicken? What is the most strong? Cannot be easily killed. Any idea of this? Before burying, the veterinarian actually inject the muscle releasing drug actually, so that the cow don't actually fight against the people there. So we can easily put a cow and chicken The problem is the pig. Well, usually 3 times more dosing of injection needed to kill the pig, no, to weaken the pig. The problem is after injection, the time actually it is around 1 minute. After 1 minute, the pig awake, and then the depth of the bearing site is 3 meters. They put the pig using the bulldozer. And then the pig actually jump up 3 meters. What the bulldozer driver can do is they have very sharp tips on their. They just using the tip. They just push the pig actually, and it can be exploded. And some of the pigs actually their legs actually detach it from their body, and after detaching, the pig actually jumped up. Wow! And then what should they do? Using the tip, they just picking, and then killing, and then burying. So what do you think about this? Can you, if you are the driver, the operator there, after doing that? After the midnight, can you sleep well? It is very, very difficult, right? So, well, this is totally but anyway, important thing is such kind of trauma actually. Well, one of the students just was telling me he just drove away from that area, and then he can see after tsunami get back to the sea at the tree, it is kind of 2 or 3 meter tree. The people actually hanging, around there. He was driving at the time. So it was very, very, So anyway, natural disaster is very, 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 significant and serious. Nowadays, man is making such kind of, serious environmental problem. You are making, actually. So, run the environmental chemistry and the reaction mechanism very well, and then you need to decide where to go. And then you go to the parliament or any places which political issues are involved, and then say something. Say your theory to save the earth. That is what you should do as an environmental scientist. Important. All right. Okay, and and one more good thing is to run this environmental science is, well, as I already told, most of the people nowadays know the environmental disaster, right? So some of your relatives, let's say your father and mother, just ask you, well, you are in the civil and environmental engineering, so I'm not, well, chemistry major also, and material science, major also. Ask you, do you know why the ozone depletion occurred in the stratosphere? Well, mother and father usually don't ask like that, but why the ozone hole happened? Now, you guys can, scientifically explain using the chemical reaction. You can show your, your theory in front of them. And also one good thing is for the guys, if you can have bright date, and then you can have good information. That is very, very important. So I will introduce the most important environmental problems, and then I will show you the reaction mechanism. And then I just ask you what kind of thing you can do to prevent such kind of significant and serious environmental problems. All right? Great. So we are actually doing ozone depletion. Well, I will introduce maybe 7 or 8 significant improvement of the gesture. You guys fully understand direction mechanism with simple chemical equation. That is it. Alright. Yeah, lots of derivatives here. Well, simply we just put some relation. A plus m goes to a star plus m. We put it. Well, actually, we can obtain the rate, kinetic rate constant by experiment K1, and the reverse reaction is K minus 1, and then here. The final reaction is A star goes to B plus C. Let's say the kinetic rate constant is K2 here. And then using these 3 equations in mass balance, we already have talked about that before. We can set up the kinetic rate expression, the concentration A over the time. Very small amount of time, very small amount of concentration, and this could be decreasing. Minus means decreasing, and plus means increasing. If you just check the all 3 equations, you can see the here A actually decreasing, right? If the direction goes, and here A star actually decreasing, right? And the final equation, you can see A star decreasing. About the for the A chemical, the first equation decreasing, and the second reaction actually A is forming, so it is increasing. So we just use a cross convention here, right? And then we can set up another equation using for the A star. This is the first equation, A star actually producing, and second one decreasing, and the third one actually decreasing, right? So using, well, this is, well, actually there is n power for it. There is n power each for each concentration, but let's assume all of the related to first, I mean 1, you know. And then using the steady state assumption, we just put it as 0. So you can have 1, you know, 2 actually equation equals 0, and then using those 2 you can manipulate, and then finally you can get this nice derivative of concentration A. dA over dt equals this kinetic, you know, equation. And then, well, this is kind of difference between the scientist and the engineer. When we, well, I am much more like the, you know, engineering-based, you know, scientist. So when you see the differential equation, what I want to do is, how can I use numerical method and then solve it, you know, exactly? That is what I want actually. But the, as a scientist side, they don't want to use numerical method actually. They just make some simplification, and also they are using, you know, proper assumption, and then make the equation simple. Then they actually can have estimation. So engineers actually doing, you know, exact calculation, and the scientists actually doing estimation. That is a little bit different, you know. So you guys can say scientist, engineer. What's the difference? You know, estimation and the exact calculation. That is different. But just don't put it in the exam, you know, paper. That can I cannot give you full credits. Well, anyway, the equation about if you assume K1m is much greater than K2, well, we can have very simple first order equation. And another case, it could be second order, all right? Then using this simple, example, let's set up the ozone and oxygen atom concentration kinetic rate equation, because we want to know, well, everybody knows how the ozone can be depleted. Well, it could be depleted by Chapman reaction, naturally, 50%, and another 3 catalytic reaction can be involved. So we want to make it, a little bit more equation, and then we can estimate, at every situation. So set up the ozone and O concentration derivatives, because we know O2 concentration already at the stratosphere, 30 kilometers. Well, most of the jet airplane, if you want to go to the Jeju Island, not Jeju Island, let's say United States or France, your country, most of the airplane want to save the fuel. So they just want to flew through the jet stream that is located at the stratosphere. So think about that. Wow, now I am in the depletion of ozone area. Yeah, you can feel that. Yeah. And there is also very acidic, solid chemical around it. Right. And then people doing set up the ozone and oxygen atom concentration derivatives. I'd like to introduce Arrhenius equation. Arrhenius. Have you heard about Arrhenius?
Yeah.
So, do you know his, well, definitely he's guy, not gay. So, do you know his nationality? Nationality.
His nationality is Sweden.
I think already, pretty reviewed the materials. Well, once you actually, see this name, when I first saw, I think this guy from Greek or some, Roman Latin, maybe he was born at the same time as the Thales or Aristotle or, Socrates. But when I met Ronald Heiss at Indiana University, he just told me at lunch table, he met him actually. Wow! At lunch table. And then he let me know this Arrhenius is Swedish, not the Danish. Well, do you know what the Denmark? Denmark is just like Korea, because at the south there is Germany there, and Germany always attack the Denmark when they have power, and upper part they have Norway, and they have Sweden and Scandinavian country. So if they have power, they always attack at first time Denmark. So Denmark is just like us. China, Japan, always they have power, they attack. So the people, the character is very, very similar. When I was at Denmark 3 or 4 months ago at Denmark Technical University, I went to 7-Eleven. I was very shocked at that time because the clerk at the 7-Eleven, he can speak 5 languages. Yeah, she nothing perfect, understandable. So it seemed like at first time she speak client with the in German, and she also can speak in French and Danish and maybe Norway, because some scholar because he can speak in Norwegian. And then the next was my turn, and I got some kind of expectation. Well, now it is time to speak in Korean. But before doing that, I kindly, ask her, can you speak Korean? She said no. Anyway, Denmark is very, very similar country to you guys. So Professor Heitz already, think Arrhenius is Danish, but he was actually Swedish. This Arrhenius equation is very, very important because if you know couple of Caniglia constant at different temperature, you can estimate the rate constant at some different temperature. This is very, very wonderful thing. Think about that. Sam, which temperature can reaction faster?
More temperature, like
Yes, higher temperature.
higher
Right?
temperature.
But some chemicals in lower temperature, the reaction goes faster. For example, as I already talked, pantherine and benzene, even naphthalene, they are kind of chemicals. The reaction hydroxyletical, actually lower temperature, it goes faster at certain range. But after that range, it follows as his theory, actually. So if we are using Arrhenius equation, well, we just do some experiment, and then we can get some more rate constant. For example, here you can see the rate constant K equals A exponential factor, exponential activation energy, and divided by the gas constant and the temperature. Right, I already talked to you. A is exponential factor, and EA is activation energy. You guys already know what activation energy is, right? So if you're using catalyst, you can lower down the activation energy. So if you are conducting some experiment using this Arrhenius experiment, you can also have activation energy. You can calculate activation energy. That is very, very wonderful thing. Not using the derivatives, most of the engineer, if you guys are senior or junior, you may expect the wow, now I can solve the differential equation using very different protocols because they actually learn the many different numerical analysis. But here you don't have to use it. Just to use the algebra. That's it. Just to put it the natural log is each side. You can get that in K and then A plus minus EA, right? And RT, right? So temperature and K, one reciprocal T and K here. If you do some experiment, let's say at 40, let's think I just want to degrade this chemical using ozone in the atmosphere because this kind of direction can occur and something. I just want to know the rate constant of K. K could be something like that. So I just want to do some reaction experiment at 40 Celsius and then 100 Celsius and then maybe 120. You can just put the right? And then do some regression. And now what can you do is you can actually estimate many other different cases at different conditions. So this is the reason why the chemical engineers and chemists want to calculate this rate constant, because using rate constant, you guys can estimate the amount of products or the amount of chemicals for the reaction. For example, if you guys want to produce AZT, which is ACE, pure drug, you definitely know how much amount different chemicals are needed to produce AZT for curing AIDS, actually. So this is very, very important, right? So using this radius equation, you can do very wonderful thing. Well, actually, I and Ronald Heights actually do some experiment using this and actually identify the relationship between the direction of, well, actually, I really want to know if I smoke, as I already told, the benzoyltyrene and many PAHs can be coated on my lung cell surface. So if I run, maybe the oxygen and ozone hydroxyl radical can be transported into my lung system. And there should be kind of chemical reaction. So I just want to calculate the rate constant. And then I did some experiment at different temperature, and then now the concentration, and then I can form this equation. Then what I should do is I just applied it to any other animal. Well, humankind, 37 or 38 Celsius, right? So other animals, maybe dog. I love it about dog, want to smoke, Well, anyway, so monkey actually. You guys cannot say monkey, apes. If you saw the movie, watch the movie, the flirt. Yes, monkey really hate the apes. Really hate the called by the monkey. Monkey is kind of very bad word. Anyway, so I saw many apes smoking actually at the zoo. Maybe you guys can estimate the rate constant, and then we publish it at the JACS, Journal of American Chemical Society. Well, engineering professor actually doing this. Isn't it wonderful? Well, and also we want to set up some kinetic equation for Chapman reaction because we are in the science, engineering student. So we definitely need to make some equation to verify, to demonstrate the environmental, reaction mechanism. Well, you guys already know the Chapman reaction from equation 1 to equation 4, and this chemical rate constant can be calculated. You may be wondering how to calculate and estimate this one. Can you do that? Or can you do that, the senior from chemistry department? You guys run chemical kinetics, right? No? No? Ah, sad. I think I'm... All right, well, anyway. But you guys know the chemical kinetics, right? Okay. So you guys know at the 30 kilometer height at stratosphere, oxygen molecule actually degraded by photolysis. Photolysis by UV, and then it can degrade it by 2 oxygen atom. And the atom can regulate oxygen molecule with the catalyst. You guys know what these are. And then it can produce ozone and M star, K2. Also, you can get the K2 by the experiment. And ozone, the produced ozone can be actually destroyed by the UV, by photolysis. and one more oxygen molecule and oxygen atom. And then this oxygen atom reacts with ozone at the stratosphere. It produces 2 moles of oxygen molecule. As you can see from K1, K4, which one is very critical? Which one is very important reaction? Well, you know, in Korean martial art, Chinese martial art, if you want to kill somebody, there are very, very critical points in human body. If you just put it, and they die, right? How about the Vietnam? Do you have such kind of martial art?
Yeah, there's so many kind of questions in religion.
Right. Well, anyway, so what do you think about this? Which one is the most significant and important reaction? If you just put it, and then you can stop the reaction, which one could it be? 이거나. 몹시 안 좋아 보이네. Do you have any idea on this? Maybe the fastest or maybe the slowest, right? So we call it, you may heard about the rate limiting step or something like that in high school chemistry class. So which rate limiting? Rate limiting is related to fastest or slowest? Stop. Miso, got any idea on this? I cannot hear you.
I think slowest one.
Yes. So slowest is most important, reaction. So we call it rate limiting, situation. So if you want to produce more and more AGT, which is ACE curing drug, what you should do is just speed up this reaction, step. So speed up the rate limiting step. You can, have more reaction products. Or in this case, if you slow down more this reaction, you can actually totally destroy whole reaction mechanism, right? So this is the reason why the airplane, flew through the stratosphere and spacing chemical, because to control this reaction. So ozone hole cannot be, occurred. At old days, United States, NASA, and the some scientific institute did that. Nowadays they didn't do that because it is very stupid, because it can cause another serious problems. I will tell you later. Right? So notice the number equation 1,4 as very constant equation around the altitude of 30 kilometer. I think you guys already did that, right? Do you need more explanation on this? No? Well, I think I just want to give you some kind of review, because this is kind of very important part to you, because this is the easiest part, when I, give the exam. Yes, sparkling, right? Great. Well, anyway. All right. So for equation, and you guys know the concentration here, O2 and M, catalyst. And then you can set up the, derivatives, rate equation for the ozone and oxygen atom, right? Using Paul equation. Setting this one is very, very easy. Think about that. Plus, minus. Plus means producing. Minus means, decreasing. So if you can find the each side, the left side, right side, you can pick it up when you can find ozone, right? So for example, ozone case here. The first equation, you cannot find any ozone, so this equation cannot be, inverted. The second, ozone can be produced, right? So using K2 times O to N, well, this is the first part of the ozone derivatives. And here, the third equation, ozone actually depleted, right? So you can set up minus, this item. And fourth equation, it also actually depleted, So you can see ozone derivation, production. You can set up the equation like this, and for the oxygen atom, you can also set up like this. Then what you should do is just put it 0, because you assume the steady state assumption. The concentration is the constant at the area, and then do some mathematical manipulation. Add these two and subtract second one from first one, and you can have two equations here. The first equation using some simple assumption, because Ronald Heights is actually physical chemist, and he really a bright guy, and can have proper assumptions very well. So using the this K1, the first term of ozone concentration case, this one is much smaller than K3O3. You can have very simple equations here, and also another equation. You can set up another one like this, and then finally you can have this final equation, and then put all of the known K value and known M concentration, and the ozone oxygen molecule concentration, and then you can have ozone concentration at stratosphere. And the problem is, this is just for the Chapman reaction, right? So we have 3 more catalytic reaction. The ozone can be depleted. So we need to estimate those 3 effects actually. So here, Lon and I just decided to add NO and NO2 cycle, because this is the amount is very important. But I can actually give you one midterm exam question. Well, you guys can develop if you are producing CFC, how the ozone can be depleted by your CFC. Set up the equation and solve the concentration of ozone. Actually, just follow this protocol. You can set up the equation, and I will give the known concentration of the chemical species, and then you can actually set up solve the concentration. And this is the definition of the ozone by the nitrous oxide and nitrogen monoxide and dioxide cycle. We can have these two lay constant by experiment, and then set up 3 mass balance equation here. Well, now I just explain mass balance equation very simply. If you have some more interest how to set up this, you guys can really can set up this one by environmental engineering way at the CE. It was 542 advanced environmental chemistry course, and you can have this reaction because as you can see, except this NO2, these are related to the Chapman reaction. But you have two more reactions here. You need to add more the influence from this reaction and put it K5 and K6 and also you want to set up the kinetic NO2 concentration derivatives here using this equation. And then you can have three kinetic equations here. And then what you should do is just put the same steady state assumption and make it 0, and then do some mathematical manipulation. So you can have here set the three equation to 0, steady state, and then subtract second from the first, and then add the third one. Wow, a little bit tricky. And you can have oxygen molecule, atom concentration here. And then what the second is add all three equation, and you can have this one and divide it by 2, and you can have another second equation. And then do some manipulation. You can have R. All right, I think the time is around already. I will continue this part again. Important thing is all of this episode can be, well, I think this is not a difficult one. So I really recommend you to go to your place and sit on chair and then summarize the issue and then the reaction mechanism and then write the chemical equation related to issues and then set up mass balance equation and then put the steady state assumption, then derive all of the related equation. You can easily get the solution, actually. You really need to do it. You can spend, if you can spend 1 hour for summarizing this, you can have A. You're not? Well, you cannot get it, actually. So you can ask what kind of grade I can have. Maybe B minus. So. All right. And then next time, I will introduce you one more interesting and significant environmental problem, issues, small. I think is it mid-March? No. Well, anybody, any idea? Student representative? Midterm exam period? Sam over there? Micah?
Week 8.
Well, she will let you know.
Week 8. It's March 26th to April 1.
Yeah.
Okay, the last week, right? Right.
The last week of March.
All right. Finally, I'd like to. So please let me know you guys are present at the Professor Park's seminar Friday. Because I was there, I know who's present or not. You guys even say hello to me. You did that? All right.
From Mary to